So in the second of these electrophilic substitution reactions, we're going to look at acylation. So we're going to remind ourselves about an acyl group. We came across those in carboxylic acids and esters. Remember that R, C double bond O, and then they're attached to something. Now, if we want to put an acyl group on, we need something that contains the acyl group, and the most obvious thing would be to use an acyl chloride. So we're going to use an acyl chloride, and the R group will depend on what we want to add. And our catalyst this time is going to be AlCl3. That's going to be our catalyst. So not sulfuric acid this time, aluminium chloride. And to ensure that our aluminium chloride doesn't react in any other way, we need to keep it dry and hydrous. I'm going to heat it up a little bit. So our general equation, we're going to take our benzene ring, we're going to add our acyl chloride. Remember that the catalyst doesn't appear in an overall equation. Can you pause the video and see whether you could draw the structure of the product? There we go. Remember that we have added the acyl group to the benzene ring and substituted it for the H. Remember that if we were to put our hand over the benzene ring, so if we were to cover the benzene ring, we can see what the electrophile would be. And so the electrophile in this case would be an R with a C with a double bond O, and then we put the plus charge on that atom that connects to the benzene ring. So how would we do that in a mechanism? Well, first thing we would need to look at is our specific example here is ethanoyl chloride. Can we write an equation? So following through, changing our R group to be ethanoyl chloride, can you draw that out? So we would have something like this. And what would we name this product? So we have to find the functional group, and in this case the most important functional group is this ketone here. This is our most important functional group, the ketone group. What's the longest carbon chain that contains the ketone? Well, it's 1, 2, so it's F and O. And now the benzene ring is a substituent, so it's a sticking off bit, so we're going to call it phenylethanone. Remember, put your hand over the benzene ring and figure out what the electrophile is. So in this case, the electrophile was a CH3 with a C with a double bond O, and then the plus must be on that. So how did we generate that? From our ethanoyl chloride. So we used our catalyst. What was our other product? Got that. Now how do we do that mechanism? Remember, it's the C with the double bond O, so I'm going to rearrange it like that with the plus on it. That's going to be attacked by the curly arrow. And do that. Can you finish it off? Pause the video and have a try. So there's our mechanism, remembering that that smiley face, that horseshoe, shouldn't extend beyond the 2 carbons either side of the substituents. And how do we get our catalyst back? Remember our catalyst was AlCl3. How do we get that back? Well, in the first step it had become AlCl4 minus. It reacts with the H plus to give us HCl, which was the other product of our overall equation. So it's our electrophilic substitution mechanism, and I'm missing a curly arrow. Let's put that on. There we go. Let's have a pause of the video now and have a go at this one. It's a little bit more complicated just because of the structure of 2-methylpropanoyl chloride, but that doesn't make the mechanism any difference. So let's pause the video and have a try. So that's our first step. The first hurdle is to be able to draw 2-methylpropanoyl chloride. Once you've done that, you can put your hand over the Cl. You know that's going to fall off that, so you know where you're going to attach your electrophile. So you know what your electrophile is. Now try to draw your mechanism. So there you go. Did you get something along those lines? So did you manage to write the reaction for generating the electrophile? Remember that this thing here, this is our electrophile. So that is what's attaching. Then I've turned it round, so I've done a little bit of a mirror of it so that I can get the C with the positive charge close to where I want to add it to my benzene ring. and then I've got my substitution occurring, and then I'm regenerating my catalyst at the end. The middle step is called electrophilic substitution because an electrophile accepts a pair of electrons and it swaps its place for that hydrogen. Electrophilic substitution.